Okay, let's get started. So hopefully we could go over everything on the homework. So sketch graph. So I'll go over curve sketching. Sketch graph of f of x equals x cubed minus 3x squared plus 4. Right, so let's just do this for example. Yeah, so similar to the previous questions, you still want to find like concavity, increase, decrease, right? So let's take f prime of x, right? I want to speed through this a bit because this was covered last time, right? How to find intervals of increase, decrease. 0, 3x, x minus 2 equals 0. So x equals 0. So these are my, critical points, critical numbers, right? And then how do you find intervals of increase and decrease? Well, you pick numbers, right? Pick a number before 0, right? Is this positive or negative? So like say -1. Well, 3 times -1 is negative. -1 minus 2 is negative. So negative times negative is positive, right? And then if you choose 1, you're going to get positive times negative. So it's negative. And if you choose a number bigger than 2, it's positive, right? So you see that from here, right? Where is it increasing? Negative infinity to 0 and 2 to infinity, right? Decreasing 0 to 2. Right, and similarly, you take the second derivative. 6x minus 6 is 0. X equals 1, right? And you can see before 1, the second derivative is negative, right? So if you plug in 0, for example, you're going to get a negative number. And past 1, it's positive, right? So it's concave down from negative infinity to 1, concave up 1 to infinity. So this will, I need you all to get a pencil and paper. So basically you want to plot these points, right? So what is it? 0, 1, 2, right? So at like say 0, what's the value? It's like 4. Yeah. Something here. At 1, it's like what? At 1, it's 2. So it's like somewhere here. And at 2, it's 8 minus, what is it at 2? 8 minus 3 times 4 is 12. So at 2, it's 0. Yeah. So after this, right, you basically, let me make this bigger actually. Let's say 4 is like right here. Maybe 4 is like right here. 2 is like right here. Okay, so here's my first question. So before 0, is my function increasing or so before 0? Is my function increasing or decreasing? And is it concave up or concave down? And down, right? I'll just write C down. So concave down means what? It's like a frowny face. So if I'm increasing and I'm concave down, which part of not smiley face, frowny face, which part of the frowny face am I? The left-hand side or the right-hand side? If I'm increasing and I'm concave down. So yeah, so it's going to look something like this, right? Like the left side of a frowny face. Everyone agree? Now you do the same thing, right? Between 0 and 1. Am I increasing or decreasing? So look here. Right. I'm actually decreasing. Agree? And I am, if you look here, I'm still concave down, right? Because concave down is negative infinity to 1. And I'm between 0 and 1. So I'm still concave down. So I'm actually like the other side of the frowny face, right? I'm like the right side. So it looks something like this. Yeah. Now again, you do between 1, let me just say 1 and 2. Right, so between 1 and 2, I am still, I'm still decreasing, right? Because I'm decreasing from 0 to 2. So I'm decreasing, and I am concave what? So concave up. So concave up, I am basically the happy face, right? So which side am I? Which side of the happy face? If I'm decreasing and concave up. Yeah, it's gonna look like the left, right? So it's gonna look like, something like this. It's gonna flatten out. And then, so again, if it was concave down, it would look like this rather than like this, right? So just so you all see the difference. So okay, so what about after 2? After 2, it's increasing and concave up, right? So it's the other side of the happy face. Everyone good with this? So you want to like find, I mean, there are a lot of questions on this, so maybe we should do one more. Like it's more work because not, the previous question is just find intervals of increase, decrease. For sketch, you still have to do all of that. So okay, so let's sketch this, right? So g prime of x is 24x squared plus 4x cubed is 0. Okay, so this is 4x if I just factor it out, 6 plus x. So x equals 0 or x equals -6, right? So same exact thing. So -6, 0. So from here, sorry, this is 0. You could test it, right? So before -6, right? This thing's negative, then the left, and 4x squared is positive, so it's negative. If I plug in like -1, it's positive, positive, right? So it's positive. And if I plug in something after 0, it's also positive, right? Everyone agree? So this is one of the case, right, where -6 is let me think, you're going down and then up. So it's a local minimum, but 0 is not a local minimum and it's not a local maximum either, right? Because it's plus plus. Sorry. So from here, right, I'm increasing. So what I would do is just say -6 to infinity, but I would put a 0 here, yeah, just to make note that 0 is a critical number that we should, and then decreasing from negative infinity to 6, right? G double prime of x. Well, okay, let's check concavity now, right? Second derivative, 48x plus 12x squared. So we set it equal to 0, right? Fine, same exact process. 12x, 4 plus x equals 0. So you get x equals 0, x equals -4, right? then, so before -4, like -5, 4 plus x is negative, 12 times x is negative. So this is positive. So between -4 and 0, oh, sorry. Yeah, -6. Thanks. Yeah, sorry, missed the negative sign. So and then -4 to 0, it should be decreasing, right? Because when you plug in -1, 4 plus x is positive, but 12 times x is negative. So positive times negative is negative. And after 0 is positive, right? So it's concave up from -infinity to -4, and then 0 to infinity, and concave down. There should be a union there, but didn't have room. -4 to 0. Yeah. So again, you plot your. In this case, it's possible that these two match, right? So here at 0, what is it? -6. Oh, it's all negative, huh? Okay, maybe I'm gonna shift my graph a bit. So here's 0, -4, -6. Yeah. Okay. So again, at 0. Oh, I don't like this. It's like a really large number. Okay, let me rewrite all this. So at 0, this is the pain of sketching. So at 0, it's like a really large positive number, right? It's like 200. At what is that -4? Can anyone do it really quick on a calculator for me? What's g of -4 and g of -6? Anyone? Are you all doing it on a calculator right now? Or okay, -50. So and then I can make it a bit down. Okay, and then -6 is okay. So let's just say it's here and here. Yeah, not fit to scale. Okay, that's not really the point. Yeah, it's a sketch. But okay. So before -6, right? So before, this is the important part. So before -6, I am what? I'm decreasing. And I am concave up, right? So you see from here, right? I'm decreasing and I'm concave up. So I am like I'm like this, right? I'm like the left side of the happy face, right? And then what am I between -6 and -4? So between that, I'm actually increasing, right? And I am what am I? I am still concave up, C up, yeah? So I'm increasing, so I'm going like this, right? And then what about between -4 and 0, right? So between -4 and 0, I'm in fact I'm always increasing from here on. But I am actually concave down, right? So I am frowny face and I'm going up. So it looks more like this. Yeah. So so again, if it was concave up, it would look like this, right? Something like that. But it's concave down. So forget the red. And then after 0, it's increase C up. So now it looks like this. Yeah. Okay. Does everyone understand this? Yes? No? So in the past, you sort of knew how to sketch, except now with the second derivative, it tells you more information, right? So before you just know increasing, but increasing, it could be like this increasing or this increasing, right? So this is like C down increase, right? This is like C up increase. So now like it's just a bit more accurate with the second derivative. And that's as far as we go. So you might ask, what about third derivative? So it is true, once if you know something about the third derivative, the graph is even more accurate, right? But you know, uh, for purposes of math 2a, we just go to second derivative. Okay, that'll be it for curve sketching. So the next thing is L'Hopital rule. Yeah. So let me just, it's pretty long, but suppose FG differentiable and G prime of X not equal to 0 on open interval I containing A except possibly at A. So again, if you see this, it means we're taking limit to A, right? Suppose limit x goes to A, f of x equals 0, and limit x goes to A, g of x equals 0, or limit x goes to A, f of x is. So this is like the cheat code to limits, by the way. So it's really strong. So you always want to use this if possible. Limit x goes to A, g of x is. So instead of infinity, I'll put plus minus. Yeah, so it could be either. Then limit x goes to A, f of x over g of x is. So it means that you could take derivative, yeah. If limit on right exists or is plus minus infinity. So let me tell you why this is strong, right? Because if you don't have a fraction, then you probably won't get undefined, agree? Like getting, undefined is like when you divide by 0 or something like that, right? So if you didn't have a fraction, then you probably don't need to use the L'Hopital rule anyway. Now, if you do have a fraction, there's 4 cases sort of, right? There's this, there's this, there's this, and there's this, right? Like if you plug it in, right? There's like, 4 different undefineds. So L'Hopital rule covers these two, right? As you can see, 0 over 0, infinity over infinity, right? Now, now you might say, but L'Hopital doesn't cover these two cases. Well, you don't need to, right? Because let me ask you a question. If you, obviously, infinity on top is a really big number. What happens when you divide by a really small number? So dividing by 0 is like dividing by a really small number, right? So if I divide a number by a really small number, do I get smaller or bigger? Like if I have a number 1 and I divide it by a really small number, does that become bigger or smaller? Yeah. So you see top gets bigger, bottom makes it even more bigger, So what do you expect this limit to be? I mean, you expect it to be this, right? Plus or minus. Same thing here, right? 0 is a really small number, right? Just think of going, I mean, it's not exactly 0 because you plug it in, right? But think of it as a really small number. And what happens when you divide a small number by a really big number? Does it? Yeah, it gets smaller, right? So you should expect this to be 0, right? So really the only hard case is here, right? Because this is really big, this is really big. What happens when you divide it, right? Which one is bigger, right? So L'Hopital rule tells you how to do that. So it's pretty strong. It covers the case you don't really know, right? So let's do examples. So let me be careful, right? It's not equal to this, right? So you're not doing quotient rule, yeah? So you're not taking, because quotient rule is, remember, it's like g squared f prime g minus g prime f on numerator, right? It's derivative of top divided by derivative of bottom. You're not taking derivative of the fraction, yeah? So just to be clear, because I know some people make that mistake. Okay, so let's do examples of this, right? So if I had like limit u goes to infinity, e to the u over 10 over u cubed, what happens? So if I plug in infinity, what do I get? Right, and that's one of the criteria for L'Hopital, right? If I have infinity over infinity, this is by L'Hopital. I can make it, I can take derivative, right? So what's derivative of e to the u over 10? So chain rule. So derivative of e to the u is e to the u, right? So you should have a copy of this. And then you take derivative of u over 10, right? That's just 1 over 10. Agree? Maybe the u is confusing you, right? But like, what's derivative of x over 10? Well, x over 10 is just 1 over 10x, right? So that's just 1 over 10, right? I mean, derivative of 2x is 2. I mean, this is just a number, right? Like derivative of 3x is 3. So it's just chain rule, right? So from here, and then what's derivative of u cubed? So that's 3u squared. Agree? So now what happens if I plug in infinity now? What do I get if I plug in infinity? Yeah. So I get infinity over infinity. I could L'Hopital again. Hopefully you see the pattern. So it's 1 over 10, 1 over 10, e to the u over 10. This thing becomes what? 6u, right? Now, again, if I plug in u to equals, if I plug in infinity, I still get infinity over infinity. So L'Hopital gives me 1 over 10 times 1 over 10 times 1 over 10 e to the u over 10 over 6. Now we get something good. So limit u goes to infinity, right? Now I get infinity over a fixed number. So what is that? Yeah. Good. Okay, so let's do limit x goes to infinity sine inverse of x over x. So if I plug in 0, what do I get? Yeah, because sine inverse of 0 is 0, right? Because sine of 0 is 0. So I get 0 over 0, which is also a criterion to use L'Hopital, right? So if you forgot, the derivative of sine inverse is just this, right? And you see, that's all we have, right? Because derivative of x is 1, right? Dividing by 1 does nothing. So, and now you have your answer. If you plug in 0, you get 1 over 1. So it's 1. Everyone good so far? So we're going to do something a bit harder. L'Hopital. So they might trick you, right? So limit x goes to 0 plus. So if I plug in 0, 0, what do I get? So if I plug in 0 for x, I get 0. What's natural log of 0? Like what number does that, basically what does natural log go to when x goes to 0 from the right? Yeah, I get like ln of 0 is like negative infinity, right? So I have 0 times negative infinity. Sadly, L'Hopital, we can't do that, right? We need a fraction. We need either infinity divided by infinity or 0 over 0. So does anyone see the trick here? How am I going to get like infinity over infinity or 0 over 0? So how about this? Do you agree that, yeah, so multiplying by like a number is the same as dividing by 1 over it, right? Like multiplying by 2 is the same as dividing by a half, right? So I can do this, right? Now on the numerator, which is ln of x, that goes to negative infinity. And 1 over x goes to positive infinity, right? When you go to 0 from the right. So I have like negative infinity over positive infinity, right? So I basically have pretty much infinity over infinity. So L'Hopital says this is limit x goes to 0 from the right. Derivative of ln is 1 over x. And derivative of negative of 1 over x is negative 1 over x squared, right? So if you simplify, again, dividing by negative 1 over x squared is the same as multiplying by negative x squared. So this is limit x goes to 0 from the right, negative x, and that's 0, right? Everyone follow? Yeah, yes, no. Okay. So we're going to do one more, and this is the case where people have the least favorite on this. People don't like this, but limit x goes to infinity, 1 plus 1 over x to the x. Okay, so this is pretty bad, right? Because if I plug in infinity, 1 over infinity is 0. So I have like 1 to the infinity power. So that's undefined. But whenever, again, what's that trick I told you? If you see a variable on the exponent, what do you do? Yeah. So what we're going to do is we're going to let y equal 1 plus 1 over x to the x. So remember, so if this is true, our goal is we want limit x goes to infinity of y, right? That's what we want. Agree? Because y is equal to this thing. But let's natural log both sides. So I have ln of y is x ln of 1 plus 1 over x. So let's take limit here. Now, this is the only tricky part, right? What's limit ln of y, right? So, and then limit x goes to infinity x ln 1 plus 1 over x. So because ln is continuous, as you know, outside of 0, right? Everything bigger than 0, right? This is the same as ln of limit x goes to infinity of y. Yeah. So if you remember, the definition of continuity is limit x goes to a, f of x is f of a, right? But there's a shorthand for this. It's the fact that you could move the limit to the inside. Right, because limit x goes to a of x is a, right? All you're doing is you're just plugging in a for x, right? So really, this is continuity, right? I could bring limits inside. And then here, let's figure out what this is. So limit x goes to infinity. So again, what happens when I plug in infinity? I get infinity times what? What's ln of 1, right? Because 1 over x, 1 over infinity is 0. So I get ln of 1. So what is ln of 1? Uh, yeah, it's 0, right? So I have infinity times 0. So same exact trick as last time, right? I need a fraction. So instead, what I'm going to do is do this. And now I could L'Hopital, because the bottom 1 over infinity is 0, and ln of 1 is 0. So L'Hopital, right? What is it? It's derivative ln is 1 of ln x is 1 over x. So it's 1 over 1 plus 1 over x. And I need a chain rule, right? Chain rule derivative of 1 plus 1 over x. Well, derivative of 1 is 0. So I just need a chain rule the derivative of 1 over x, right? The reason I do this is just because, the bottom is also derivative of 1 over x, right? When I do L'Hopital. So I mean, you could calculate this, but I'm just saying these will cancel, right? So all you're left with is, well, from here, this is 0, right? Do you agree? Because 1 over x, 1 over infinity is 0. So 1 over 1 plus 0 is 1 over 1. So it's 1. Okay, so I have this equals 1. My goal is to find this. What do I do? I have found ln of my goal. So what should I do? Yeah, you raise both sides to the e, right? Raising both sides to the e, it gives you that limit x goes to infinity of y is e to the 1, right? So your limit is e. Yeah, so the same thing for like any other limit with variable in the exponent. You just use natural log, bring it down, take limit, use continuity for the natural log, and then your answer should be like e to whatever limit you get, right? So, okay, everyone clear on this? Yeah, so I think that should cover like the L'Hopital limits on your homework, if there are any. Okay, so moving on, optimization. So basically, the best way for me to say is finding max min, right? But in form of word problem. So before we had like a first derivative test, right, for local max, local min. That's if like, on like a locally, right? But you could think of it the same way, right? So there's like a first derivative test for absolute extreme values, right? So instead of an interval, it's basically, on the whole real line. So if f prime of x is bigger than 0 for all x less than c, and f prime of x is less than 0 for all x bigger than c, f of c is absolute max. Makes sense, right? Because if before c you're always increasing, like always, right? Because f prime of x bigger than 0 means you're increasing. So if you're always increasing before c and you're always decreasing after c, you must be the absolute max, right? So no, this is for everything past c, right? So be the opposite, right? Less than c and f prime of x bigger than 0 for all x bigger than c, f of c absolute min. Everyone get this? I don't think it's that hard of a concept. So let's just do like 2 problems on this. Yeah, x less than c. Yeah, so again, if if before c you're always increasing and after c you're always decreasing, you must be the absolute max, right? So let me just do example. Find dimensions of rectangle with perimeter. So for these questions, you either want to use like a closed interval method. So if you remember, if I give you a continuous function on a closed interval, there must be absolute max and min, right? If you remember, you find critical numbers and then test the boundary points, right? So you either try to make it a closed interval or you use that first derivative test I showed you like 30 seconds ago. Whose area is as large as possible. So here is an optimization problem. I want to max out the area, right? So I want to find I want to max out A. So if my rectangle is x times xy, what's the area? Good. I want to max. So sadly, we haven't learned 2 variables, right? There are ways. Later you'll learn in multivariable calc how to find maximize stuff with 2 variables. So that's why they give us this, right? So most of the time, your equation has more than 1 variable. So but the information they give you is to make it 1 variable, right? So I know the perimeter is 2x plus 2y, right? And they tell me it has to be 100. So in other words, for example, 2y is 100 minus 2x. Y is 50 minus x, right? Everyone clear on this? So again, how I want to maximize this, right? How do you find max and mins? Well, I take derivative, set it equal to 0, find the critical number, right? So derivative of this is 50. If you like, this is a of x, right? So this was a of x, y. But now that it becomes a of x, and then you're finding a prime of x, right? And then you're setting equal to 0. So you see x is 25, right? And you can, and in this case, you have two options, right? You can use the first derivative test that I just showed you 30 seconds ago. So here, you know that before 25, it's always negative, right? Sorry, always positive. Sorry. And after 25, it's always negative. Agree? Do you all see that? So first derivative test tells me by first derivative test. X equals 25 gives max area, but they want your answer is the max area, right? So when x is 25, y, well, what was y? Well, y is 50 minus 25, so it's 25. So the max area is 25 times 25. Yeah. But another way, in this case, you could actually use the closed interval method. So if you don't want to justify it using the first derivative test, we're actually in a closed interval. Why? So first off, if x is like the width, right? Can width be negative? Can you have like a negative width? So this is like real life scenario. Like, does it make sense to have a rectangle of like negative 5 centimeters of width? Yeah, so this should be bounded by 0, right? Maybe you have 0 width, so maybe you're just a line, right? But you can't be negative. And certainly from here, right? Do you see that x must be bounded by 50? Because if x was bigger than 50, right? 2 times x if x bigger than 50. 2 times x would be bigger than 100, right? Then 2y would be 100 minus 2x. Well, this is a negative number, right? So that would mean if this was true, then that would mean y is a negative number. And by same reasoning, you cannot have negative length, right? Do you all see that? So you sort of have these bounds, right? Everyone agree? Yes or no? So you actually used close interval, right? In this case, it's a function of x. So you have a continuous function on the closed interval 0 to 50, right? So what do? You test values, right? So you find a critical number, and how would you find the absolute max? You plug in a of 0, a of 50, and a of 25, and whichever gives the biggest number is your max, right? And whichever one gives you the smallest number is your min. In this case, this is 0, because if you look here, 0 times whatever is 0. This is also 0, because 50 minus 50 is 0. And this is 25 times 25. So this would give so whichever way you want to do things, yeah. Sometimes you cannot get a closed interval, so you have to use this, right? And then there's like analogous one for like second derivative. But yeah, so if you see an optimization problem, right, write out the equation, right, take derivative, set it equal to 0, use the test, right? And and make sure when you're taking derivative, it's only in one variable, right? So if the equation has like multiple variables, then they have to give you information to like, you know, change this to like the other one. Yeah, because this is a single variable calc. So okay, does everyone understand optimization? It's like basically finding max min, but in the form of a word problem. Okay. So so I guess next time I will go over the last thing, antiderivatives. It shouldn't take long, and then I'll just leave the rest of discussion. It'll probably take like the first 10 minutes, and then I'll leave the rest of discussion for like any questions you have before the final. Yeah, for like final questions. Yeah. Everyone does that sound good? Or okay, cool. All right. I'll see you all Thursday then.